In this video, we'll be looking at our review for our solving equations test. Problem number 1, negative 42 equals negative 6y. Our goal is to isolate the variable. In this case, that means we want to get y by itself. We notice we have negative 6 times y because connected means multiply. We will use the inverse operation. That is, we will divide by the coefficient negative 6. Whatever we do to one side, we do to the other. Negative 6 divides negative 6, leaving y. Negative 42 divided negative 6 is 7. We believe that y equals 7 is our solution. We will substitute to verify. Substituting 7 in place of y, we have negative 42 is equal to negative 6 times 7. Using our calculator, we can verify this is a true statement. Negative 6 times 7 is a negative 42. This is true. So we can say that y equals 7 is a solution. Remember to pause the video between each problem to try on your own. Number 2. Our goal is to isolate our variable, in this case get h by itself. We notice we have 2 times h plus 3. In general, we will undo the added or subtracted part first. I'm going to draw my line down the middle. This is just to keep separate. What I do on one side, I do to the other. Here we have plus 3. Our inverse will be subtraction, subtracting 3 on both sides. Plus 3 minus 3 sums to 0, leaving 2h on the left. Equals in the middle. 9 minus 3 is 6. We want to get h by itself. This is 2 times h. The inverse of multiply is divide. Dividing by our coefficient 2 on both sides. 2 divides by 2 to leave h. 6 divided by 2, that's 3. We think that h is equal to 3. We will substitute to verify. Instead of h, we're substituting 3. Plus 3 is that 9. From this statement to this statement, in place of h, we have substituted 3 because we believe h is equal to 3. Well, 2 times 3 is 6, plus 3, that's 9. 9 is equal to 9. This is a true statement. Since this statement is true, we know h equals 3 is a solution. Number 3. Our goal is to isolate the variable. In this case, x. We want to get this x by itself. Looking on this side of our equal sign, we're not concerned with the left side in this case. We know that x is over here in my right expression, so I need to deal with this minus 3. Well, the inverse of subtraction is addition. So to undo our minus 3, we will add 3 on both sides. Minus 3 plus 3 sum to 0, leaving only x on the right. Equals in the middle. 5 plus 3 is 8. We believe that x is equal to 8. We will substitute here to verify. 5 equals, instead of x, we will substitute 8. Is 5 equal to 8 minus 3? Yes, it is. 8 minus 3 is 5. This statement here is true. Since this is true, we know that 8 equal x is a solution. We could rewrite this using our symmetric property as x equal 8, but these two statements are equivalent to each other. Number 4. Our goal is to isolate our variable x. Right now we see we have x divided by 3, subtract 2. Well, we need to undo both operations that we have going on here. First, we will undo our subtraction. In general, we will undo the added or subtracted part and then the multiply and divide part. Notice that we have x divided by 3, then subtracted 2. When we undo in the opposite direction. We'll undo the minus 2, then we'll undo the divide 3. So, first adding 2 to both sides. Minus 2 plus 2 cancels, leaving only x divided by 3. We're getting closer to getting x by itself. Equals in the middle. 3 plus 2 is 5. Well, we want to get x by itself. What's going on between x and 3? It's division. What's the inverse of division? It's multiply. So I will multiply by 3 on both sides. I'll simply connect to 3. We know connected means multiplied. Whatever I do on one side, I'll do on the other. 3 divides with 3, leaving only our x. Technically 1x, but we know it's an implied 1 here. 5 times 3 is 15. We think x is equal to 15. We will substitute to verify. In place of x, substituting 15. 15 divided by 3, subtract 2. Is that 3? Well, 15 divided by 3 is 5. 5 minus 2 is 3. This statement is true. Since that statement is true, we know x equal 15 is a solution, because a solution is a value that makes the statement true. A. Number 5. We want to isolate our variable. In that case, it means to get m by itself. Notice here we have two m's, but they're on the same side of the equal sign. When they're on the same side of the equal sign within the same expression, we can combine like terms. Like terms means the same variable to the same exponent. Here we see we have 2m's to the first power, so we're simply combining 3m plus 4m, and that is 7m. Everything else stays the same. We have not subtracted 3 on both sides. We have not added 7 on both sides. We have simply noticed that 3m plus 4m is the same as 7m. We have simplified the left side of this expression by combining the like terms, 3m and 4m. Now we have our variable and with some constant is equal to some constant. We're typically pretty good in this position. Solving for m, we will first undo our added portion. It's plus 4, we'll subtract 4. 4 subtracts 4, leaving 7m. Equals in the middle. 25 minus 4 is 21. We have 7m is equal to 21. We know that connected means multiplied. We'll undo this multiplication with division. Dividing by the coefficient 7. 7 divided by 7 to leave 1 m, we simply say m. 21 divided by 7, that's 3. We will now substitute 3 in place of m. 3 times m, but instead of m, 3. Plus 4 times m, instead of m again, 3. Plus 4. Is that 25? We could use our calculator to evaluate this, but 3 times 3 is 9, 4 times 3 is 12, 9 and 12, 21, plus 4 is 25. This is a true statement. So we know that m equals 3 is a solution. It's a value that makes the statement true. Number 6. 10 plus 2 times the quantity 3g minus 4 equals 26. When we have a number connected to a parentheses, we will employ the distributive property. In general, if there's distributing to be done, we'll do it first. 10 remains the same. 2 times 3g will be a 6g. 2 times 4 will be 8. We will preserve our operation. If this were a minus 2, we would change these signs and change this operation to addition. Connected means multiplied. The 2 is being multiplied by this difference. Said another way, the 2 is being multiplied by the 3g. The 2 is being multiplied by our minus 4. Now we have one similar to our last one. This time we have the like terms 10 and minus 8. They're like terms because they have no variable part. 10 minus 8 is 2. 6g remains the same. 10 minus 8 is plus 2. Technically, we should rearrange these terms using our commutative property, changing this to a plus a negative and rewriting this so it's 10 plus a negative 8. But we can simply see that it'll be 10 minus 8, and that will be 2. 6g remain the same, 26 remain the same. Now solving for g, we will undo our plus 2 by subtracting 2 on both sides. 2 subtracts 2 to leave 6g. 26 minus 2, that's 24. Solving for g, we will divide by our coefficient 6 on both sides. 6 divides 6 to leave g. 24 divides 6, that's 4. I should substitute 4 to verify. I'm going to leave that to you. G equal 4 will be a solution. Number 7. 3q plus 10 is equal to 9q plus 4. This time we see we have variables on both sides of our equal sign. It is inappropriate to combine these. We should not say 3q plus 9q is 12q because one is in my left expression, one is in my right expression. When there are variables on both sides, I will try to eliminate one of my variables. In this case, I'm going to eliminate this q on the right-hand side by subtracting 9q. Simply look in front, it's a plus q, we will go minus 9q. Whatever we do to one side, we do to the other. Notice how I line it up with his like term partner there. 9q minus 9q is 0, leaving only 4 on the right-hand side. 3q minus 9q is a minus 6q. Plus 10 remains. When there are variables on both sides, we will begin by eliminating one of the variables. You'll see that leaves us with one variable on the left plus or minus a constant is equal to some constant, and we're pretty good in this position. Solving for q, we will undo the added or subtracted part first. In this case, subtract 10 on both sides. Ten subtracts 10 to leave our minus 6q. 4 minus 10 is negative 6. Solving for q, we'll divide by our coefficient, negative 6. Negative 6 divides negative 6 to leave q. Negative 6 divided negative 6 is 1. I will show my substitution here. 1 in place of q, I'm left with 3 times 1 plus 10 equal to 9 times q, where q is 1. 9 times 1 plus 4. 3 times 1 is 3 plus 10 is 13. 9 times 1 is 9 plus 4 is 13. This statement is true. So I know q equal 1 is a solution. Number 8, we see we have some distributing to do first. We'll take the 9 and multiply it by both terms in the parentheses. 9 times r will be 9r. 9 times 1 will be 9, leaving the right side the same. Again, we have variables on both sides of the equal sign. When there's variables on opposite sides, we'll get rid of one of them. In this case, it's a plus 3r, I'll subtract 3r. Whatever I do to the right, I'll do to the left. 3r subtracts 3r to leave 45. 9r minus 3r is 6r. Plus 9 remains. Solving for r, we will first undo our added or subtracted first. Minus 9 on both sides. 9 subtracts 9 to leave our 6r. 45 minus 9 is a 36. Dividing both sides by our coefficient 6. We want to get this r by itself. It's 6 times r, we divide by 6. 6 divides 6 to leave r. 36 divided by 6, that's 6. We see that r is equal to 6. We could take this fact that r is 6 and substitute it back in. 6 plus 1 is 7. 9 times 7 is 63. 3 times 6 is 18. 18 plus 45, also 63. We can see that r equals 6 makes this statement true. So we can say r equals 6 is a solution. That concludes this video. There will be a separate video for the remainder of the problems.